Hey everyone, just wanted to talk today a little bit about a lot of the discrepancies in the South, um, particularly more below the equator, as far as discrepancies with distances and mileage. And the further south you go, generally distances are going to be much greater, um, whether that's Australia or South America or Brazil or even Antarctica or the Southern Ocean. Anytime anyone navigates down there, we've came to find that there's many discrepancies with the miles that they're navigating, and we've come across this in many different ways. Now, to kind of give you a better idea, if you're on a globe, the bottom of the equator should be the same as above the equator. So whether you're in the northern hemisphere or the southern hemisphere, it should be the same distance. But obviously, on a flat plane, that's going to be a greater distance the farther out you go beyond the equator. It's going to be drastically greater distances. But again, if you're on a globe, this distance around the below the equator should be equal to the distance around above the equator. But we're going to show today and demonstrate that that's just simply not the case. And we're going to demonstrate a few ways of how we came across this. One of the things we've come across is with globe races, a lot of the distances that have been navigated are far beyond what they should be navigating. A lot of the world records for the greatest speeds are actually held up north in the northern hemisphere, and the speeds are much slower in the southern hemisphere. Another thing we came across is there's certain flights that just don't work in the southern hemisphere. Some of them you can't even book a nonstop flight. So we're going to cover some of the flights also. Another thing that we'll cover is the Argo floats, or the Argo fleet of smart buoys, and how the distance they cover and the cycles they cover is much greater than what it should be. And also with the undersea cables that most of the world uses for internet and communications, they don't really work in the South. There's none from Africa to South America or South America to Australia. They just don't cover great distances in the South. And we're going to go into that in a little more detail, how the undersea cables just don't work on a globe, particularly in the South. Another thing we're going to go over is briefly cover is just a few parts from this book called His Pronouncement by R.G.S. Collymore, and how a lot of different people that have navigated down south were finding that they were covering much greater distances than they should be, and many mileage and many other issues, discrepancies that they ran into the further south they got. And this has been documented for hundreds of years. So we're going to cover quite a bit today with these discrepancies, but let's go ahead and start off with some of these issues and cover a little bit more details on it.
See the same thing with the world record of the sailboat races, where the world record speed in the south is way slower than in the north. Why is that? Because they're actually going further than they think. They're calculating speed based on that equation of speed equals distance over time, assuming a globe distance, and it's taken them way too long to get over a short distance, so they get a much lower speed. What a recurring theme. That's such a coincidence that things just decide to go way slower in the south. Like, well,
why do you accept those sailboat races but not the ones around Antarctica?
We do accept them. Do you know what the record... Here, how about this? So the boat that did the Vendée Globe got the record for going around or whatever. Those boats that go around, they do their whole little trip, they get back, they do the calculations, and they come out that they were doing 4 knots. Okay? 4 knots. For the world record of going around the southern hemisphere. When the boat, go look up the boat does 35 knots. Guess what? There's a current that goes west to east of 2 knots. So how is it that boats magically slow down to 4 knots. And it'd be like me telling you I broke the world record for driving a car. Be like, really? How fast did you go? Be like 45 miles per hour. You'd be like, what are you talking about? Cars go way faster than I go. Well, they didn't in my race. My race, I won at 44 miles per hour.
But wait, look, here's the world record in the north. It's going 220. And you're like, no, but dude, I set the world record in the south. It's 45.
Right.
All I can.
So weird.
Right. So an average of 4
Can you
knots.
not at least admit that's kind of, isn't that, do you see what we're saying though? Like in our paradigm, the south is way bigger, right? And what a coincidence that the world record of the boats is way faster in the north than in the south. But it would make sense if they assume a globe. So they assume a symmetrical distance in corresponding northern and southern latitudes, right? And so then they do their little race. They assume that distance, and they're taking way longer to do it. And they're like, what's going on? That must mean we're going way slower. Or they're actually going fast, just like the boats always do, but they're going further than they think they are. And so they assume the shorter distance of the globe, and they get a shorter.
And we only believe this
speed.
because there's an accumulation of evidence.
The Antarctic sailboat race, which they have every couple of years, they don't even.
Yeah, I actually have that written down.
Yeah, they don't go near Antarctica. They can't even see Antarctica. They're like at 50 degrees south, 40 degrees south at some points. And even on their website, the last time they did it, there's one leg of the race from Africa around Antarctica and then over to South America. That leg, which is a big leg, was 32,000 miles, according to the race. Wait a minute. The equator is just 25,000 miles. How did just going around that little 13,000 mile continent turn out to be 32,000 miles? And then they had another 10,000 miles to go to finish the race. How are they going around Antarctica and making a circle bigger than the equator? Weird? Can I get a weird?
Can you explain that one in a different way? I wasn't able to follow that.
So if you look at Antarctica on a globe, it's a continent at the bottom of the globe. It's kind of a circular continent, and they tell us it's about 10 to 13,000 miles in circumference. So if you wanted to sail around it, you would go about 13,000 miles. Okay. So the Antarctic sailboat race, they have you've seen those sailboats. They're the most high-tech sailboats in the world. They're amazing, right? These are the fastest sailboats in the world. And they're saying that the one leg of the race, which is like 2/3 of the race, was 32,000 miles. You got to remember the equator, which is the biggest circle you can put on a globe, is only 24,900 miles. So how did that one leg become 32,000 miles? The other thing is, when you're out in the ocean, you don't know how far you're going, because if you're not over land, you don't know how far you're going. The only way to be told your distance is GPS, pretty much, right? And GPS is run by NASA. And so when they look at it, they say, okay, the trip took us 30 days or whatever it was. I forget it was 30 days, 60 days, whatever the amount of time it was. And they say, okay, well, at 50 degrees south, the race should have been like 18,000 miles or 20,000 miles, whatever it was. So they take the time divided by the distance, and they say, well, the average speed was 3 to 4 miles per hour. 3 to 4 miles per hour. Now, are those boats those boats can go 3,000 to 4,000 miles an hour when they're tied up at the dock, right? 3 to 4. The reason it's coming out like that is because they're traveling a much bigger distance than they're being told. And so we had at least one of those sailboat captains has come on our shows saying, I know how they're faking it. The earth is flat. We're sailing much greater distances. They're using magnetic declination to hide the flat earth, because there is no magnetic declination on the flat earth. It's only on the globe that you have magnetic declination. Go ahead. Sorry. I'm talking a lot. So you guys ask.
No, totally fine. And that was going to be my next question is, are these people that are taking part in this race, are they being lied to, or are they lying?
No,
that was my big question.
They're not even being lied to. They're being lied to by GPS, the ground positioning system. But some of them are figuring out. Other people are like, oh, well, I guess it was a big current. I guess, these guys the boats are going 20, 30 miles an hour at times. But the average speed is 3 to 4 miles per hour if you take the time and the distance that they've traveled.
The distance.
Yeah.
Okay.
And, and it's hard for them to figure it out, because they're like, well, we're at 60 degrees south, now we're at 40 degrees south, and we're here. These guys, when they're done, they're sailors. Okay. They're not there doing math. They're there, sailing as fast as they can. And I don't know why they all don't speak out when they hear that they only were going 3 or 4 miles per hour. They should all know. They should all know, but it's willful ignorance, if they don't. But a couple of them have spoken out. And
now we're going to briefly go over the tracking of these two major globe races. We have the Vendée Globe race on the left and the Golden Globe race on the right. They essentially both take the same racing route. They both start in Vendée, France, and they go around the main capes and then back up to France. Now, the Vendée Globe race uses much faster racing yachts. They use the IMICA 60 yachts, whereas the Golden Globe race uses much slower yachts. They use pre-1989 yachts, so they don't sail as fast. The Vendée Globe race uses GPS, and all the other globe races, like the Antarctica Yacht Cup race, use GPS. The Golden Globe race is the only race that does not use GPS. Now, with that being said, the Vendée Globe race on average takes about 90 days to complete, and the Golden Globe race on average takes about 260 days to complete. So obviously it takes much longer to complete this Golden Globe race than the Vendée Globe race. Now, with this being said, if we take the distance over time to complete these globe races, with the average cruising speed of the IMICA 60 yacht on the Vendée Globe race at 15 knots per hour, 17 miles per hour, the 90 days that it takes for it to complete, if we take the distance over time, that is about 414 miles per day on average, which comes out to about 37,281 miles to complete this Vendée Globe race. If we even factor in the Antarctica current, that is going to take about 45,900 miles with the 4 mile per hour Antarctica current factored in for the Vendée Globe race. And the Golden Globe race, with the distance over time of the Russell 36 yachts at 6 knots or 7 miles per hour, it's 168 miles per day times 260 days. It comes out to 43,680 miles. And with the Antarctica current of 4 miles per hour, that comes out to about 68,640 miles. So now you have a major mileage discrepancy of, nearly 20,000 miles. Not only is this much larger than the Equator of, a little over 24,000 miles, but why is the Golden Globe race traveling nearly over 20,000 miles further than the Vendée Globe race when they're actually racing, essentially the same exact route? This is because this 20,000 mile difference is because the Vendée Globe race uses GPS and GPS boundary safety waypoints, whereas the Golden Globe race does not use GPS, and that's where the 20,000 mile difference comes from. So obviously we can see there's major mileage discrepancies that simply do not work on the globe model. Another thing I briefly wanted to point out on these globe races is, some people might think, well, these numbers you're figuring, you're not figuring them sleeping, for the 24 hours. And thing is that these sailboat captains on these globe races, they actually they navigate for the full 24 hours a day for the entire globe race. And what they do is they actually train their bodies to take these short, like half-hour half naps, and they'll take these little cluster naps throughout the day, and they train their bodies for years to take these short half naps. And they'll actually see like neurologists and sleep specialists to train their bodies to take these short naps so they can, constantly be sailing as much as they can for the full 24 hours. And they do sail for the full 24 hours. So what they do is, like, for example, with Ellen MacArthur, who did the Vendée Globe race, she's seen a neurologist to train her body to sleep an average period of 36 minutes in these little cluster naps. And a lot of times she would only get 1 to 2 hours of sleep a day for the entire duration of the Vendée Globe race. And the same thing with Francis Gabar, he would sleep in 20-minute half naps. So a lot of times he would only get a couple hours of sleep a day but the boat would always be sailing for the full 24 hours. So they try to, get the best speeds they can so they don't ever stop on these globe races. So those distances are actually, figuring for the full 24 hours because they're actually navigating for a full 24 hours. A couple of things I want to go over here briefly is that they're also using to cover up these greater distances on these globe races is the magnetic declination charts that they follow to hide the true nature of the larger size down south and hide the true nature of the Antarctica coastline. But also it's going to cover these greater distances. But I also want to show you how these meridian distance corrections are built into the GPS that they also follow on these GPS waypoints on these globe races. So let's go ahead and cover that a little bit more in more detail.
So you start clicking around here, and you're going to see the declination here. This right here, this value is telling you how much of a correction you have to make. And when you're in Antarctica, right, you get negative 42 degrees, you get all these crazy things. If you come up here where you're going to say, look at the Southern Star Trail, say you're in South America, you got declination corrections all over the place. Look up here, negative 23 degrees, negative 16, negative 6, negative 5, which means your compass is going to say one thing, you have to correct that many degrees to actually get what they're saying real south is 27 degrees. So you see that when you're looking at the Southern Star Trail, say like, okay, I'm going to look over at the Southern Star Trails from Africa. Well, my compass says one thing. Now I need to correct 17 degrees to really be looking south. And then you're claiming, oh, the Southern Star Trails are exactly where the globe would predict, directly south. They're all moving around a point. That isn't true. Okay, so that's a major point that I just made. This is a fact. And if you actually, just while we're here, if you look at Antarctica, gets crazy, bro. Probably a coincidence, right? Negative 47, negative 76, negative 112, 171, which means that's almost 180 degrees. If you go to Antarctica, you pull your compass out, it'll say north, and you need to turn around and look the other way to actually be facing north. That's what your model says. That when you get to Antarctica, the corrections are insane. Negative 96, negative 112, plus 167, that the compass is like completely wrong everywhere in Antarctica. Well, that's convenient, because why is it not symmetrical? Why doesn't it do that in the north? Right? How come when we're in the north it doesn't do that? We don't see any type of numbers like that in the north. Look at the Arctic. Why are we not seeing like 180 degrees up here? Isn't that weird? Shouldn't it be symmetrical? So, anyway.
I also wanted to show some more details on these GPS safety boundary waypoints and these built-in meridian distance corrections that are built into the GPS boundary waypoints. We can see here these safety boundary waypoints are between 45 degrees and 55 degrees. This keeps them away from, quite a bit of ways away from Antarctica, but it also keeps them from going to the more dangerous turbulent waters below 60 degrees south. Now, a lot of this information is actually released to us from a retired French sailboat globe race sailboat captain named Hervé Raboni, who told us about these GPS safety boundary waypoints in several interviews. Now, these GPS boundary safety waypoints, they follow these throughout the globe race, and this guides them through the race. Now, these safety boundary waypoints, again, they have these meridian distance corrections that are built into the GPS, which is what causes these major mileage discrepancies where they're navigating, nearly 20,000 miles further than what they should be if they were actually navigating below the equator. Now, a lot of these GPS meridian distance corrections were discovered by GPS engineers and physicists decades ago. One of them was a physicist named Paul Marmot, who wrote the GPS paper called The GPS and the Constant Velocity of Light. This detailed a lot of the built-in corrections. Basically showed that the raw GPS data was already Sagnac corrected, and it had corrections for relative simultaneity, Sagnac effect, and also meridian distance corrections that were built in between the meridian lines on the GPS coordinate system. So these meridian lines here, they had meridian distance corrections that are baked in. So this would basically cover the longer distances that would be navigated below the equator. And they also use globular to flat coordinate transformations to allow for spherical excess and the longer distances travel below the equator. So it's all hidden in the coordinate system. Now, what I was saying, they do globular flat coordinate transformations. The GPS is basically like we can take the GPS data from, let's say, Lisa Blair's Antarctica quote-unquote circumnavigation, and we can plot that same coordinate transformation onto an azimuthal equidistant map, and we can plot all her coordinates onto that Gleason's map, and she's actually going around the interior circumference of Antarctica and not around the outside, as was what would be shown on here. So they're actually navigating around the interior circumference of Antarctica, and this is all baked into the GPS coordinate system and the coordinate transformations. So with that being said, another thing we could look at is, we know that they're not actually going around the outside of Antarctica, but they're actually navigating around the interior circumference of Antarctica. One way we could look at that is how they're actually navigating. If they were navigating around the outside of Antarctica, they would always generally have to be steering right. And if they were navigating around the interior, they generally always have to be turning to the left. So let's actually look at a previous sailboat captain that completed the Vendée Globe race. Let's see what he has to actually say. There is Francois Gabard, who won the Vendée Globe race. Let's see what he actually says here.
Et un tour du monde en bateau, c'est très très simple. Hein. Oui. On descend l'Atlantique, on tourne à gauche à chaque fois, et puis on tourne. Comme si on faisait le tour d'un lotissement. Enfin, je veux dire, il faut toujours tourner à gauche. Si on hésite à un moment donné, il faut tourner à gauche.
C'est extraordinaire ça.
So not only does there huge mileage discrepancies, but this adds to more conclusive evidence that they're actually navigating around the interior of Antarctica and not the outside on these globe races.
So I'm just showing this average flight is like 12 and a half hours from Sydney to Santiago, and if we just pick one of these, we'll go this one here. I'm just going to press play so we can see. So this flight here. Oh, this flight did a little funky moves here. But if you just take the mathematics of this and we say, okay, so this flight in 12 and a half hours is 7,062 miles. So we're just going to take that here. And 7,062 miles divided by the 12.5, and we get 564.96. Okay, so that is a probably Mach 8.5 as it is, right? And I think the speed of sound is like 650 or something at that altitude. So they tell us, again, we don't know that. This is just what they tell us. But if that's true, just think about it, that plane's going 564. Now, remember, we've shown and know, and I've got papers that say that there's a 300 up to 350 mile per hour jet stream. And it says, we now understand the jet streams really well. And there's this jet stream, and this one goes up to 250 miles per hour, and this one goes up to 350 miles. Nowadays, they don't mention that at all. You'll not find a mention of a 350 mile per hour jet stream. However, I have a paper written in the 60s that talks about it as if it's just everyday knowledge that this is something everybody should know. So if that, let's just say it's a 150 mile per hour jet stream, you're talking about that plane actually going then 414. So now we've got planes in the south that are flying slower than any plane has ever gone in a long distance flight. Why is it flying 414, taking the 150 mile per hour extra, going 564 and doing that trip in 12 and a half hours? Now, again, I've shown that if a plane at Mach, let's say Mach 9 is, let's say 600 miles per hour. I don't know, 0.9 I'm talking about. Let's say it's 600 miles per hour and there's a 150 mile per hour jet stream. So that plane would be going 750. So if we take 750, so we're going to take 7,100 divided by 750, and we'll get 9.46. So that means that a plane should have done it in 9.46 hours. And if we go down here, you will never see a flight for even 10, let alone 9. So now we have to believe.
Exactly.
Now you have to believe that in the place where they tell us that the biggest jet streams are, the place that they tell us there's the fastest moving wind, that now there's planes that have never gone a normal speed. They tell us that planes in the north go like 840. right? They're like, oh, this plane broke the record. It went 840 or 850. So again, if it went 850, then why has no plane in the South ever done that? It should have happened once. They should just have gone, hey, we got a lucky
where
win.
the jet streams are stronger.
Winds are faster. Yeah, that's
Right.
crazy.
So
it says
well, every time I try to answer this, I try to tell them, go to 24/7 flight radar. The data is not matching up. It actually goes against the globe. And then they look at me like I'm speaking Chinese, and then they turn around and claim that I had no answer for it.
I mean, I just did 850, which is the speed that they say the planes in the north are going, times 12.5 hours, and you get 10,625 miles, which is 3,500 miles further than the plane goes. So again, there's just problems in the South that cannot be explained. And this is the paper I'm talking about, the atmospheric meteorology here, atmospheric jet streams in the aerospace age by Herbert, whatever his name is. But you'll notice down here he's talking about how now they're going to use this for all flight planning. And the course of modern meteorology has been guided by this discovery in many ways. Jet streams affect surface weather, the principal cloud, and weather systems are associated with it, but it has its problems of aerospace science and technology that the most direct account must be taken of the atmospheric wind concentration, which they do twice a day from 1,000 locations. We shall look briefly at a few of these problems. Multiple jet streams. Following the first discovery, the concept was proposed of a single dominant jet stream per hemisphere, but observations soon rudely upset this simple picture. It is now clear, notice that, it is now clear that the jet streams will be encountered simultaneously at various latitudes and altitudes. At this time, we have definite knowledge of the following currents. And you'll notice this one here says, the subtropical jet stream of winter, latitude 25-35, course speeds occasionally approaching 300 knots, which is about 350 or even more miles per hour. And then mean height 40,000 to 45,000. Planes can easily get that high. People think that there's a ceiling of 40,000. There's not. Planes can go for 45,000. You'd have no idea. And you'll also notice that there's westerly and easterly, meaning people think that the jet streams go one direction. But this talks about here a westerly current, meaning it's coming from the west. This one's a westerly current coming from the west. The easterly jet stream means it's coming from the east. So you do get different jet streams going in different directions. And this one's at 75,000 feet. What is that one? The polar night jet stream, roughly around poles from west at latitude 60-65 in the winter. Core height, at least velocities recorded above 200 knots. Strong meanders and asymmetries of position are common. So anyway, I think this is also the paper somewhere in here that talks about the South being the fastest, and a lot of that stuff's getting scrubbed. So anyway, my point is long-winded, that there's tons of reasons why I'm in the position I am or why I believe what I believe. And it's okay. I think we've talked about this before, but at 1,000 feet layers, they have different jet streams. Sometimes you're at 55 or 35,000 feet, and then at 36,000 feet, the jet stream is going the other way. So, and they must know it really well. I mean, if you've gotten up in the plane, once you're up at cruising altitude, the flight's pretty smooth. So it is really like somehow there's like a there's like a freeway up there or something.
Yeah, well, yeah, that's how the NASA says they control their balloons with the electrostatic tethering, right?
Right.
It'll be following one jet stream one way, and then it'll get too far, so they'll either raise it up or lower it down and catch that other jet stream, and it'll come back the other way.
Yeah.
So they got it pretty mapped out really well, I'm sure.
I mean, this guy is just funny. This guy's talking about at this time we have definite knowledge of the following currents, and then now this is never mentioned, like it doesn't exist. And again, these are the things they could hide from you. They don't need to tell people that there's a 300 mile per hour jet stream, because if the computer knows it and the computer's doing the flight planning, not even the pilot needs to know. Nobody needs to know how fast the winds are, except for the computer system that's planning the flights and getting people to where they need to be at a certain time. So there's enough questions that people should, like Austin just said, at least say these are weird things. There's no cruise. There's no container ship that just goes across from New Zealand to South America or Australia to South America in direct shot. Now they've got every excuse in the book. Oh, it's too far, and it's out in the middle of the ocean, and you could have an emergency, and they've got all these different convoluted excuses. But it's weird that they all match our version of the Earth. Right, that's what's weird, is that how do all these things line up? So it's undersea cables. There isn't something. So there's lots of problems in the South. There's not a lot of planes that fly across this, not at all. I think it's the QF-27, QF-28, and then most of these go to like these little islands up here, and then But again,
and aren't they special planes? They have like 5 extra layers of paint and all this kind of crazy
they're all
stuff.
Composite materials. They've all been redone. It used to be the ER version of the extended range version, but now it's called the Dreamliner 787-9, which is the newest long distance craft, and the ones that fly that Qantas route, and also the one that goes Auckland to New York or something, that kind of long flight. So this one here, it's got, all the different composite materials, and it's got further extended range. It replaced the extended range flight. So anyway, they've had a couple fires on board. But anyway, you can read this if you want. That's under there. You can go down here to the -9. I believe they show each type. Flight testing, and there's the different types. So here's the -3. So it just says it's a lengthened and strengthened variant, 20-foot longer fuselage, higher maximum takeoff weight. It features active boundary layer control on the tail surfaces, reducing drag. It's going to replace the ER version. It'll replace the Airbus 3300 and 3300. So anyway, there's lots of things about this plane, and we're not going to know everything about it. If there is any kind of reinforcement, do they have to mention it to us? I don't think so. Not when it's kind of this kind of deception that would be very easy to pull off. That's what I think is so weird, is that this is not a difficult one to pull off with the flights, at least to me. I don't think that that's the least of our worry. But all those things tell me that there is something in the South that's weird, something that doesn't match the globe. I do have somebody.
So basically, like, you're showing that the recorded pings from the GPS are showing that the plane's going a lot faster than they report that it goes.
Yeah, exactly.
Yeah.
We can see the differential speed between flight radar 24 and the computer here.
Wow. Right.
Again.
Oh shit! What the fuck?
Again here, and again here, and as we see.
Oh my god, bro!
This
Whoa!
It's
Sorry, these are southern flight.
Listen, because it's pretty interesting here. It's the same day, okay? It's the same day, and this one was going. Let me get straight. West to east, and this one was going east to west. Look at the differential speed. Like maybe a jet stream? I don't know.
Yeah. Let me hold on. Let me show you this real quick and see where that lines up. Where's that at?
Let me 2 seconds.
How many hectopascals is 40,000 feet?
Sorry?
Well, 1519 kilometers per hour. Is that what it was? Or was it 1319? It's like 940 miles per hour, which is insane.
Fam, we're talking about submarine cables, and there's an interesting thing about them, which is the way that they're laid out. Check this out. There's none from southern country to southern country. Now, they help power the internet and transmit 99% of all international data, again, from southern country to southern country and again. Now, here's another projection of them, again, none from southern country to southern country and again. Now, up here, we got a little bit that connects, and I'll show you how that works. So right here is the only part that connects. Check this out. Now it makes a little more sense when we map it out on an AE map, aka what a flat Earth map would be. So it goes from here to here, but it doesn't go from down here to over here, or from South Africa to Australia, or from Australia to South America. This is why there's no sea cables that connect, because the distance is way further than what they tell us, and coincidentally, there's no cruises that go from South America to New Zealand or South America to Australia. Probably just a coincidence.
For example, I think this southern no boat, no cables is pretty much as close to the proof that you can that the Earth's flat. Okay, because nothing else makes sense. It's at the bottom of a globe, and the cables wouldn't even need to be run as far as you're thinking. On a flat map, when it's spread out, those cables become much longer. Okay, so to me, why wouldn't they have boats that go across? What about freighters, things like that? No. So I find this site, which is called Slow Travel, makes a lot of sense. All right. So in this thing here, you can pick these sailing trips. Okay, so you'll see here, Argentina, Antarctica, South. Okay, well, I want to go on a trip, and I want to find freighter travel. So you can actually get on a freighter, one of those things with a bunch of boxes. And so, okay, where do we want to go to? So Europe to, Asia to. So we want to go South America to. Let's go South America to. South America to, Europe, Asia, South Africa, South America, North and Central America. What? Where's Oceania? Where's New Zealand? Where's Australia? Okay, let's go there. Maybe we'll start there and go this way. So we go, no, that's not. Expedition sailing trips. Australia, New Zealand. Okay, great. We'll go there to South America. Europe, Asia, mail ship travel, North and Central America. It's really weird that everybody thinks that there's these magical boats that can go. No, why? Because they would prove that the Earth is flat. Okay, quite simply, it would prove that. So you've got these continents. So let's say you've got North America, South America, Africa. I know this is just quick and kind of all this over here. Okay, now we've got Russia over here. Okay, so kind of a flat Earth like that. I know it's a really bad drawing, but I'm just kind of showing you. Okay, and we know that we've got Australia down over here and New Zealand here. Okay, so this is much longer than on a globe. Much longer. Okay, but on a globe, we actually have people going. Let me show you a globe here. You'll have like down here's Australia. Okay, you got these things here. You got Japan around here, kind of like this, and then you got North America and South America here. Okay, on this side of the globe over here, you have boats leaving here. Let's do a different color. This red. You have boats leaving here. They go up here. They like go all along here. They go all along here. They go all the way down here to get to South America. Okay, that makes no sense. If you're going to take a boat that's going to go from here to here, it goes to all these islands. I've calculated it before, and like it's way over the amount of time that you would need. And it would say like at island from 8 to noon, leave noon, sail 2 days. But there's always all these extra days in there. Like you don't need 2 days to sail between those two islands. You could just do the math on the distance even that they give you. So why is there no boat that just does that? Why is there no ship or cruise ship that just does that? And the reason why is because we know that a cruise ship goes 20 miles per hour. Can it top out at 25? Maybe. So if we know that, then there's a big difference between 6,000 miles and 9,000 miles. Okay? And we could just do the calculation. So I say force it on them. Force them to prove it. Now, all right. So these undersea cables, when you look at the layout here, there's a good picture. Yeah, you can see good enough. I mean, this is funny because if you look at this kind of layout and do like me, you spread it out so it becomes like a flat Earth map. So right now that's kind of a Mercator. We're going to spread it out. What's the only place that would break is any line here. Any sea cable going in this direction down here would break. Everything else can fold. Everything else, you see how these lines are just, it's funny too because everything's at this like Mecca point here, this home point, and it would all bend out from there. You could bend all the wires would just bend out. And I'm not saying we have to bend anything, but if this map is truly a flat Earth map and now has been like this, then it would make sense to me that all those cables would stay connected. And why don't we have anything here? Why is there no boats going here? Like I said, boats will leave here and they'll go all along up here, all over here, maybe out to here, maybe down here, maybe come this way, but they'll never just go across here. Why? Because this is a much larger distance. And I don't know if there's really better proof. And again, nobody can ever find a boat that goes, nobody can ever find a cruise ship. If you go look hard enough, you can find a cruise ship that has 15 stops all along these islands and takes 72 days. Okay? You can go and calculate it. You're not going to figure anything out. You don't know how. It's just, even their itinerary would be wrong, right? It's not going to be correct. It's not going to say exactly what days are going and everything. And the other one is, don't they also have, here, it's kind of hard to see. See if I can find one on this side of the page. This is good. So they also don't connect them here and here. So it's really funny to me that, and then look at flights. Flights all go this way, right? That doesn't make sense. Why would you go here and then here? Like Dave always says, why would you cross the equator twice? You wouldn't. But on a flat Earth map, all of a sudden that makes a difference. Let's look at that real quick just so we can finish this off. Earth map. Images. See if we, okay. So yeah, in this. So you got this issue here where now all of a sudden this cable can't exist. This cable can't exist. This cable can't exist, which is exactly what we get. And you have this Mecca point here in Hawaii that branches off to all the different locations. So, yeah, anyway, that book that I read has some crazy quotes about, I mean, there's like entire islands that were found and then not found and then proclaimed to be wrong and then they found again. And it's because there's some discrepancy in the South, which is easily explained when you realize that the South is much larger than any of the guys believed and they thought it was a globe. So that's why one guy would go down there, Wilkes or somebody. He would discover some huge swap of islands, come back and tell everybody. They would write them on the map and say, okay, it's here. Then the next trip that would go out, they would go to that same spot and say, no, there's no land here. So then they would erase it and say, no, there's no such thing as land here. And then all these guys had the same problem of 11 to 20 miles a day being off reckoning. They didn't have any of those problems in the north, just in the south.
Yeah, exactly. It's called His Pronouncement by RGS Collmore. Yeah.
And I sent it to you on Telegram, right? Is that right?
No, it just freaking destroys the globe. These people in the early 20s and 30s were just destroying the globe. Yeah. And you'll hear the anti-flat earthers. They'll be like, people have been using celestial navigation for hundreds of years, and we know it works because it's the Earth's a globe. It only works if the Earth's a globe. No, actually, when they were still using celestial navigation based on the stars, as recent as the 30s, 40s, they had huge discrepancies in the south, and now we use GPS. So,
right,
GPS that's the point. That's how they got away with it.
GPS is our baby. GPS is the savior of everybody, because if people still had to navigate by the stars, they would start to notice the problem. Nobody does that anymore. Nobody's going to go take out their sailboat and just be like, I'm just going by the stars today. They're not even going to try it. They're not going to put their life on the line like that.
Aren't they doing the whole Antarctic race or whatever, as close as they can to it without GPS?
No, that's all GPS.
Go to page 49.
49?
And yeah, look, it says, many sea captains and officers haughtily assume to tell us about it because it is their profession, but STS Lecky Mariner, previously referred to, tells us how little they know and how ignorant they are on the subject.
This one here is talking about all the different boats that have been sunk because of the South. Here's, reading this part here where it talks about D'Urville finds Charlie Land, but Mawson denies its existence. Wilkes finds a large stretch of land that now bears his name, but Scott and others called it a myth, only to have Mawson rediscover it. Shackleton finds no trace of South Greenland, which is duly charted, and Amundsen and Captain Davis find no trace of Emerald Island, also charted. The Carnegie experts deny the existence of the Royal Company Islands, which seafaring men declare do exist. All of these various claims and denials relate to the region south of the equator towards the alleged South Pole. Such variance induces the following questions. What kind of observations of latitude and longitude did Captain Scott make when he failed to find Wilkes Land, a stretch of land over 1,200 miles long, equivalent to the distance from New York to Havana? Right, so 1,200 miles is huge, and Captain Scott didn't find Wilkes Land, right? So, but it's there. So it's like they must have been so off in their reckoning, and if it's just as easy as, we just look at the stars, we know where we're at, I don't think that's the case. I think that they were told it's a globe, getting very confused when they were down there because things weren't where they should be.
Exactly.
Mawson, go ahead.
You see where it says it talks about like in the South Sea voyages by Ross. We found ourselves every day from 12 to 16 miles by observation in advance of our reckoning. By our observations at noon, we found ourselves 58 miles to the eastward of our reckoning in 2 days. And then the United States Exploration Expedition, in less than 18 hours, he was 20 miles to the east of his reckoning and 54 degrees south.
Right. So,
dude, as soon as you start to get to like 55 degrees,
everything
completely falls apart. Oh, how convenient. They say you can't even get on a ship and explore the waters past 60 south.
Can't store fuel. Exactly. That's when you get turned around. That's what,
exactly where they report the biggest discrepancies.
Right. So yet Mawson found it and reported it, and his findings were corroborated by Shackleton. What kind of observations of latitude and longitude did Mawson make when he failed to find Charlie Land, found and reported by D'Urville? What kind of observations of latitude and longitude did Shackleton make when he failed to find New South Greenland, which is duly charted? The same question may be applied to Amundsen, Captain Davis, the Carnegie experts, relative to the Emerald Island and the Royal Company Islands, respectively. Here's from December 9th, 1920. I was talking about all the disasters that have happened, the boats that have been sunk because people can't figure out where they're at. So it says a year's record to June 30th showed 222 American craft foundered, and 555 figured into other misfortunes. All of the other nations have similar lists. It is difficult to understand, with all the wonderful inventions now at hand, how there could have been so many collisions and sinkings. The sea yet takes its toll, and there is much marine work to be done, so much in fact that it may take generations of men to complete it. Comparison with the estimates of the conclusions of the Literary Gazette, 1861, Builder, Goompak, 1862, all reveal such important reports, mysterious happenings, and significant warnings that people should certainly consider the subject seriously. I think it goes into the North Pole from here, which isn't as crazy. But I do believe this is here. It says, when we look at a map of the Northern Hemisphere, one that has the equator for its circumference, such a map compels the realization that the Arctic is not the top of the world, but central, with its reference to the lands on which we live, that radiate from it as a hub. You will probably discover that in comparison with the rest of the world, the Arctic is much smaller than you thought. You may discover, too, that you cannot buy in England a map that shows the whole Northern Hemisphere in the sense in which numerous maps. So I think that the North is smaller than we're told, and that's how they kind of make up for the South being much larger, right? If you make the North smaller, then you can actually have the south of the equator be correct for the most part, and then as it gets, like Austin said, when you get to 50 or something, then it can just break down completely, and they just make sure nobody can go there. And I wouldn't be surprised if the equator was 21,000 miles. I don't think we could even figure that out. I don't think anybody would know. And the way you don't know is because of GPS. That's why it doesn't matter, because planes get to where they're going and they self-calculate their speed, or they just know the destination they need to get to. We don't really know the ground speed that they're going unless you're basing it off GPS. So it's the way.
But we just move on. And one example of some of the discrepancies, and there are many, right, is check this out. So there's something called the Argo fleet, and it's these smart buoys, right? And you can track them. They should be going at the current speed, let's say 1 miles per hour. So to circumnavigate at 60 south latitude should be 15,000 miles or 15,000 hours, which is about 2 years. I'm looking at buoys that have been going 7 years and are only 3/4 circumnavigating. They've only done 3/4 circumnavigation. So if you do the math, the boat has gone 61,000 miles. In the south, just like the world record for the speedboat is way faster in the north than in the south, because they think they're going a shorter distance, which means they think they're going a slower speed. But in reality, they're going a greater distance. The same boat, just in the south water, has a significantly lower, world record speed. Okay, and then of course you can keep going. When they started going into the south, assuming that there was a symmetry of a sphere, they constantly got lost. They were off by hundreds of miles. It didn't work. Right? They had to create all kinds of magnetic declination charts that tried to correct for it. Many different sailors, like veteran sailors, saying, "We're in the south, all of a sudden it doesn't work. Assuming there's a sphere and that it's symmetrical doesn't work." Okay, so why do we not have a map? That's why. That's the answer. Because you can't. You're not even allowed to patent one without the assumed coordinate systems of longitude and latitude of a sphere. Right? That's the answer. And if you actually look into truly verifying and testing some of these distances, they fall apart. GPS will be wrong on like a 17-mile bike ride. So people can assume it. You're driving in your GPS, quote unquote GPS, is correcting as you go. You think it worked.
Yeah, you have to know how to use maps. Maps have different scales and different things that you look at. But bottom line is that all maps are wrong. The projection map, one of the Mercator maps.
Not sure if you mentioned the discrepancy, but the north has 21 time zones, 24 at the south, and 27 time zones crossing Australia. Yeah, discrepancy is a little bit more than that, but yeah, there are more time zones in the south than in the north. I have a whole stream about it. Yeah, you can travel off of the updated transform coordinate systems, but in the south, you have to actually be able to verify the distances. And that's not being done at all. And all the data and facts and evidence and information shows that there is significantly more area in the south, which is why it takes way longer to do things in the south, because they're going way farther than they think they are on the globe, which explains all the southern discrepancies. Vast majority of all transportation happens in the north, right? Undersea cables go from northern to northern continent, but not south to south, right? All the trade routes, they want to go north to north. Oh, 95% of planes that fly from the south, they pop up north, then come back down. It's overwhelmingly obvious that the south is consistently different than the north, when it should be symmetrical, whether that's flora and fauna, plant and animal life, everything. Okay, I mean, this is all that people say, the map, oh, the map, and it works. You can't get past that. You don't understand how that works. You don't understand that you just put it into a spherical geometry coordinate system. You transform it. You make updates and corrections. That the north would practically be the same. Like you guys don't get that? It's weird.